Hello and welcome to another Python object-oriented programming lesson. Today, what we're going to talk about is inheritance. So by the end of this video, you should be able to demonstrate an understanding of what inheritance is and understand the concepts of method overriding and how we use the keyword super. All right, so a little bit about just the concept of inheritance in general. So if we are, kind of thinking in general right now, not just specific to coding, but if we're establishing an inheritance relationship, we're typically establishing a kind of like a hierarchical relationship. You have a more general, a more generic category or group kind of at the top of a tree, and then you might have more specific children or subclasses that umbrella underneath it. So for example, we could have a hierarchy of all the different animals, and I can't fit them all on one slide. There's just a few examples here. But for example, if we were going to kind of list out some different animal groups and show how they're related to each other, we might start at the top of the tree with, as general as we can be, animal. Underneath animal, there's lots of different classifications, different types of animals. We might have fish, mammals. Underneath mammal, we might have cat, dog, and we could break this down a lot further. We could add a lot more groups to this, but when we're talking about inheritance, these are the types of relationships we are defining, okay? So a few more specifics. So we're defining relationship hierarchies. What this allows us to do when we're writing code in Python is we can actually avoid having to define attributes or methods in multiple classes. So for example, kind of looking back at this animal hierarchy, if there is some method that all animals should have, instead of writing that in every individual animal class, we can write it once at the top level in our animal class and never write it again. Okay, so using inheritance is a good way to avoid redundancy in your code. And one thing that is unique to Python that is not unique to every language, Python is a language that supports multiple inheritance. So that means child classes, subclasses can inherit code from more than one parent class. This is not true in every language though, so as you're jumping between languages, this is definitely something to be aware of. Make sure you look up before you get too involved in your design. So let's look at an example of how we could actually implement inheritance in Python. So here I already have a really simple class written, an animal class. I just added a few attributes to it, one method. So the way it's written right now, I'm saying that all animals, regardless of what specific type of animal they are, they're all going to have some type of name. They're all going to have some level of hunger. I'm imagining this to be like a numeric value, like on a scale of 1 to 100, how hungry are they in this current moment. They're going to have a specific diet. Maybe they're an herbivore, maybe they're a carnivore, maybe they're an omnivore. I don't know, but we should keep track of that. Okay. And then I define the method eat because all animals need to eat. And then I've left it at that. So this is a very generic definition of what an animal could be, right? So I've kind of condensed that into a UML diagram here so that there's a little bit less stuff on the screen. So we could represent any animal with this class. But let's say I wanted to write a class to represent a more specific type of animal. I'm going to pick dogs because they're my favorite. If we were going to write a dog class and use inheritance so that this dog class inherits the attributes and methods from the animal class, that means that I do not need to re-add these attributes like name, hunger, diet. The dog is, if it's extending, if it's inheriting from this animal class, It already has those. So when I write my dog class, I actually only need to add the things that are unique to the dog class. So a few things that might be unique to dogs. They have a breed, a particular breed. Not all animals have that. They might have a property. Are they an indoor dog or an outdoor dog? Okay, maybe a Boolean variable, a Boolean attribute there. Some actions that are unique to dogs. I think fetch is a good example. Not every animal fetches, so this would not be a good method to put in my animal class because it doesn't make sense for all animals, but it is something specific to dogs that I can include here. All right, so we already have the animal classes. This is the same animal class I showed you just a second ago. Now, if I was going to implement the dog class as you saw it in that UML diagram, this is what it would look like. So I would create a constructor for my dog class. I'd have the new attributes that should be included in the dog class. I would have that new method that should be included in the dog class. Okay, but the dog class, it looks like it's smaller. If you just look at the code, there's fewer lines of code in my dog class. So if I were just to ask you which class is bigger, you might be tempted to say the animal class. Okay, but when we're using inheritance, we have to think about this a little bit differently. The parent class is actually the smallest class. The parent class has its attributes, its methods, no one else's. Okay? However, just like the boys who are cheating on their test here, the child class has its attributes, its methods, and it knows everything that its parent knows. Okay? So this boy in the middle knows a little bit more than the boy on the right, and the boy on the left actually has access to the most information because he gets to combine his knowledge with both of the boys on the other side of him. Same thing with a parent-child class relationship. The classes at the bottom of the hierarchy actually have the most attributes, the most methods, even if the class file is not that big. Okay. So when we think about what attributes and methods our dog has access to, we have to think about not just the things that are specifically in the dog class, but also all the attributes and methods defined in the parent class. Okay. Another thing that you will see a lot of when you are implementing inheritance. So if we look back for just a second, so there are 3 attributes, name, hunger, and diet, that are actually defined in the parent class. So if we only call, if in our constructor for the dog, if we want to initialize those 3 attributes, we actually have to go and call the constructor for the parent class. And if we just call init, again, inside of init, the compiler is going to be like, okay, weird things are going to happen. You're not going to end up with the result that you want. When you, from within a child class, want to go and use a specific attribute or method from your parent class, there's actually a special keyword that you use. You use something called super. So in the pink here, where we see super.init, name, hunger, diet, what that says is go call the constructor for the animal class and initialize these attributes. Okay. So what this is called, this is referred to as method overriding. And that just means, so in the dog class, we have overridden init, okay, with a dog specific constructor. If we don't do that, then when you run the code, you will run the method that's in the parent class. So another example of this, so right now there is an eat method inside of our animal class. So if we don't have to write another eat method in the dog class, if we create a dog object and call eat, it's going to refer to this method here that exists in the animal class. But we do have the ability to override the parent eat and come up with a specific version of eat for dogs. I don't know what your experience with dogs has been, but I know my dogs, they eat everything in sight, even if they are just the slightest bit hungry, even if I just fed them. So I feel like dogs will eat even if they're pretty much full. So I have redefined the eat method for the dog class to basically, if they find food and they have even the slightest amount of room in their stomachs, they should eat it. This is not the same for all animals. So if I have a dog object now and I call the eat method, it's going to look first in the dog class. Because it finds an eat method, it will use that eat method as opposed to the one defined in the parent class. Okay? So to sum everything up, we can use classes to define these relationship hierarchies where we have children or subclasses kind of at the bottom of that hierarchy, and they inherit methods and attributes from their parent class. This is also, you might see the parent class is referred to as superclasses, the child class is referred to as subclasses. And this can be really useful both to make your code a little bit more organized and to help you reuse code so that you don't have classes and classes and classes that have exactly the same methods defined in them. That gets really repetitive and it's inefficient.